about 14 billion years ago with the Big Bang. After that, it took about 9.5 billion years, also according to NASA, for our sun to finally form. At around the same time, according to Live Science, so about 4.5 billion years ago, the Earth formed. But it would take almost another billion years, according to BBC, for the first life forms on Earth to form. That was 3.8 billion years ago. But according to NPR, humans have only been around for about 200,000 years. So basically, it's taken the entire 3.8 billion year history of life on Earth for humans to come about, and basically the entire 14 billion year history of the universe for us to appear. But did it have to take so long for intelligent, conscious beings like ourselves to form? What if I told you that right now, as I'm giving this speech, a conscious being could pop out of thin air right next to me? And what if I told you that the possibility that that could happen could derail science completely, making it impossible for science to describe our universe as a whole? Let's explore this idea. But first, before we do so, we have to understand two concepts: Boltzmann brains and typical observers. Spread about evenly across the entire universe is an energy known as the vacuum energy. And I represent the vacuum energy with these white dots on the screen. And it fluctuates about, which is why they're jiggling. No one knows why this energy field exists, but scientists know that it does exist, because when they look out into the universe, they see that the universe is expanding. And the only explanation for this expansion is the vacuum energy. Now, you may be familiar with the concept of the space-time continuum, the idea that space and time are one and the same. Similarly, there's an idea in science that matter and energy are one and the same. From matter comes energy, and from energy comes matter. Now, keeping that in mind, as quoted in New Scientist, regardless of its origins, vacuum energy is active and always fluctuating. Occasionally, enough to transform into particles and matter. So because of fluctuations in this vacuum energy, it's possible throughout the universe for matter to literally appear out of thin air because of the fluctuations. Now, usually this matter is a photon or an atom, maybe a molecule. But theoretically, a big enough fluctuation in the vacuum energy can bring about any form of matter. A big enough one can bring about a star or a planet. And theoretically, a perfect fluctuation could bring about, say, an exact replica of my brain. Now, obviously, that it seems impossible, and it's certainly extremely improbable. But you may have heard of a concept known as the infinite monkey theorem. As described by NPR, given enough time, a monkey randomly striking keys on a typewriter will end up banging out a copy of Hamlet. Yes, given an infinite amount of time, a monkey banging on a keyboard will write out Hamlet and all other books. Similarly, given enough time and space, the vacuum energy will fluctuate perfectly enough to form, again, maybe an exact replica of my brain or an exact replica of this room with all of us in it. So though it seems rather strange, definitely, and it's definitely extremely improbable, we have to remember that space is enormous. And the universe has been around for a long, long time and will continue to be around for a long time. And given enough time and space, even what seems improbable will become probable, and not only probable, but certain. And that's what a Boltzmann brain is. It is a conscious thinking being that appears out of thin air because of a fluctuation in the vacuum energy. Now that you understand what a Boltzmann brain is, let's look at typical observers. An observer is just a conscious being that observes the universe, so we're observers. But a typical observer is an observer whose observations and experiences are similar to those of most or all other observers in the universe. So, here we are, us humans on this planet. Let's say that in the entire universe there's one more planet with life on it, and there are intelligent beings on it. It's across the galaxy somewhere, and it has these aliens. And just like us, These aliens took billions of years to evolve, and again, they live on a terrestrial planet like us orbiting a star. If this were the case, we would be typical observers because our observations and our experiences would be, relatively speaking, pretty similar to these other observers out there. But what if those were not the other observers in the universe? What if there were trillions and trillions of brains floating in the middle of outer space observing the universe? We could not be considered typical observers because our observations and our experiences would be drastically different than these brains just floating in space. And if there were trillions and trillions of them again, and there were just 7 billion of us, there would be so many more of them observing and experiencing the universe in such a different way that we would be not typical observers, we'd be anomalies, we'd be outliers. And that's where the dilemma comes in with science. Let's take a quick step back and remember how we got here. We got here with all these steps, and it took billions and billions of years. Boltzmann brains get here like that, in an instant. So if the universe keeps on going forever, and it keeps on expanding because of the vacuum energy, and everything keeps getting pushed farther and farther apart, one day gravity won't be able to pull things together and make stars and planets and allow for billions of years of evolution that are required for beings like ourselves to form. No, eventually the only beings that will be able to form are beings that form out of thin air, Boltzmann brains. And so eventually, if you take a look at the entire infinite history of the universe, you will see that one day, these Boltzmann brains will outnumber conscious beings like ourselves. There will be infinitely more brains floating in the middle of outer space than human beings or other ordinary observers like ourselves, and we will therefore not be typical observers. And again, this is a huge problem, because according to astrophysicist Adam Becker, the starting point for our understanding of the universe and its behavior is that humans are typical observers. If we are not, our theories begin to look iffy. You see, if our observations and our experiences are based on outliers and anomalies, if what we see is not typical of the entire universe, then scientists cannot take the observations they make from here on Earth and apply them to the entire universe. Again, our observations wouldn't be typical, so we couldn't expect that that's how the universe works, that the way the universe works here in our outlier of a solar system, it works the same way in the entire universe. Therefore, if the universe keeps on expanding forever and Boltzmann brains outnumber us, we are not typical observers, and scientists cannot, they simply cannot, it's impossible for them to create theories about the universe as a whole. Now, I'm not just telling you this because it's kind of fun to think about the possibility that a brain can appear right here next to me, or that maybe science can't explain the entire universe. I'm telling you because that means, or if you think about this, that such a strange and simple idea that maybe a conscious being could appear right here next to me right now, if such a simple idea could derail science, could make it impossible for science and scientists to explain the universe as a whole, then where is science leading us? Can science answer all the questions that we have about the universe? And can it explain the universe as a whole? Or is there a better way to explain the universe? Is there something else that we need to look for? Right? As of now, no one knows. And as of now, I guess it's just up to you.